Hello everyone and welcome back to the tutorial series. In this part of the tutorial we will be going over how to remotely access the EC2 instance that is running one or more processes of the Unreal Engine server executable in the fleet hosted on Amazon GameLift. Remotely accessing GameLift fleet instances is useful for troubleshooting fleet activation issues and server crashes. It is also useful for looking at server logs in real time and much more. So with all of that said, let's get started. But before we get to remotely accessing an EC2 instance, I just want to quickly address a mistake from the last part of the tutorial, as well as some modifications to the start matchmaking Lambda function that I believe should be made. However, these changes are not necessary, so if you want to move on to the part of the tutorial when we remotely access an EC2 instance, then we will have a timestamp on the screen for when we start doing that, and you can just skip to that timestamp in the video. Moving on, I first want to address an error from the last video that someone in the comments kindly pointed out, so go ahead and open up your Unreal Engine project in Visual Studio. Once your project is open in Visual Studio, go to the top and select Development Editor as your solution configuration, keep Win64 as your solution platform, and then go to Solution Explorer, right click your project and select Build, because at the end of the last part of the tutorial, after implementing backfill changes, I only rebuilt and repackaged the game server, but I never recompiled the game client. Now you may be asking, how does that work? So after we repackaged the server the first time in the last part of the tutorial, we also repackaged the client because some of those code changes affected the client. In between the time we repackaged the server for the first time and the time we repackaged the server for the second time, the only files we modified were the GameLift tutorial game mode header and C++ files, and one file in the GameLift server SDK. The game mode for the server map will only exist on the server, not on the client, and the GameLift server SDK plugin only exists on server builds, not on client builds. Just to quickly show that last point, I'm just going to go to the project in File Explorer and open up the Windows No Editor folder, because that is where the package client build is located. And if we open up the GameLift tutorial folder here, where the plugins would be located, you'll see that there's no folder called plugins. Therefore, all the changes made to the project after the first time we rebuilt the server would not have affected the game client, so the old client can still be used for connecting to the new server. However, as you guys can see down here in the error list window, if I scroll down past the IntelliSense errors, when I try to rebuild the game in a non-server configuration, there are build errors, which is an issue because maybe some of you guys want to add more changes to the client. So let's quickly fix these compiler errors in the GameLift tutorial game mode C++ file by double clicking this first error that says the stop backfill request method must return a value, and that should take us to the last line of code of the stop backfill request method inside the GameLift tutorial game mode C++ file. Because that's where the mistake is, and essentially the mistake I made here is that this method is of return type bool. So the method has to return a bool value, but any code inside the hashtag if with underscore GameLift and hashtag end if compiler directives are only included in server build. So when building the project in a non-server configuration, the compiler ignores all the code inside this method body inside the hashtag if with underscore GameLift and hashtag end if compiler directives, which in this case is all the code inside this method body. Therefore, in the compiler's point of view, the stop backfill request function is blank and thereby doesn't return anything, even though the function has to return a value of type bool, which leads to the build error that says a GameLift tutorial game mode stop backfill request must return a value. So to fix this, all we have to do is add a return statement to this function outside the hashtag if with underscore GameLift and hashtag end if compiler directives, and you can literally make the function return any value of type bool, because this will be an unreachable return statement in server builds and the game mode will only exist on the server. So type at the end of this method return false. Now to fix the other build error, which says a GameLift tutorial game mode create backfill request must return a value, double click that build error, which will take you to the last line of the create backfill request method in the same GameLift tutorial game mode class for the exact same reason the stop backfill request method was incorrect, except this method's return type is fstring. So it has to return a value of type fstring, which is not happening currently for non-server build configuration. So let's fix that by adding at the end of the function, outside of the hashtag if with underscore GameLift hashtag end of compiler directives, return, and then a pair of double quotes. And remember, once again, what you choose to return here does not matter for the same reasons I mentioned for the stop backfill request method. Once you have added those two return statements, go ahead and build your project again. Once the project has finished compiling in the development editor configuration, you should notice that after adding those changes, the build was successful, so you can start making changes to the client again if you want to. And note that this will not affect the server because, once again, those two newly added lines of code are unreachable return statements for the server. So I am not going to repackage the server, and I am not going to repackage the client either, because those changes were made to the server maps game mode, which does not affect the client. Now we are going to perform the steps necessary for remotely accessing a Windows EC2 instance in your GameLift fleet. But first, go to the GameLift dashboard in the web browser of your choice and select the last fleet that we made in the last part of the tutorial. It should have used the latest version of your project server build, which in my case is 1.0.2. So I'm going to click on the name of this fleet that says underneath the GameLift tutorial 1.0.2. And from here, make sure you have the scaling tab selected. Now if it's not selected, then just go ahead and click on it to select it, and then go down to where it says auto scaling policies. Because in order to remotely access an EC2 instance in your fleet, you actually need a running instance in your fleet. Right now, by where it says manually adjust the desired instance count to, it says 0. And the value is 0 because after the last part of the tutorial, I decided to manually scale down the fleet so that I wouldn't have any instances running, because I knew I wasn't going to be using this fleet for a while. So remember guys, if you know that you are not going to be playing or testing your game anytime soon, make sure to set this number to 0 so that you don't get charged, because you end up paying for how long each active instance in each of your active fleets runs for. For Windows instances, it's by the hour, and for Linux instances, it's by the second. All of the costs of GameLift and other AWS services used in this tutorial series will be covered in a future part of the tutorial. But for now, I need a running instance to show you guys how to remotely access one, so change this number from 0 to 1, and if this currently said 0. Then click on the checkmark button to save and apply your changes, and then go ahead and pause this video for some time and occasionally refresh the page until the numbers appear, so under where it says active instances, until this number goes from 0 to 1, and then under where it says active servers, until this number becomes a number, until this number changes to a number greater than 0, because once again we need at least one running instance for this part of the tutorial. After this part of the tutorial, if you are not using your fleet, you can set that number we just changed back to 0 so that you don't get charged for an idle instance. Okay, now that we have one active instance and at least one active server process, let's go to command prompt and start typing some AWS commands. Now remember from past tutorials to make sure that your AWS CLI is configured correctly by doing AWS space configured. I'm not going to press enter because my AWS CLI is already configured to the account I was just logged into when I was looking at the GameLift dashboard in my web browser. So first we need to get the ID of the instance running in our fleet, and to do this we need to run the GameLift describe instances command. So type out AWS GameLift describe -instances, and this command will take in one parameter called fleet ID. So type out --fleet -ID space, and before pressing enter, go back to your fleet page that we were just looking at in the GameLift console in your web browser, and copy the value underneath where it says fleet ID, and then go back to the command prompt and just go ahead and paste that value in. I usually paste the value in here by doing a right mouse click and then go ahead and press enter. And what you will get back from the scribe instances is information about each instance in your fleet currently. Right now, an array containing one object was returned, but you can actually configure your fleet settings in the scaling tab to have more than one instance running in your fleet simultaneously. It's just that in this video, we only have one running instance in this fleet. So with the information about the instance, we can now get access to the instance by running a different command called GameLift get instance access, which will get us credentials and other information that we will use when trying to access the instance. So type out AWS GameLift get -instance -access, and then this command will take in two parameters. So the first one will be --fleet-id, and the value for this will be the exact same value that we use for the fleet ID parameter that we pass to GameLift describe instances. So I currently don't have the fleet ID copied to my clipboard anymore, so I'm just going to select this fleet ID value here by where it says fleet ID in this object in this instances array. I'm going to copy it by pressing Control C, and actually you can use either the right mouse click like I suggested before, but you can also use Control V to paste values in command prompt as well. And then the second parameter will be --instance -id, and for this the value will come from the information returned from described -instances. So by where it says instance ID in the same object in the same instances array, just go ahead and copy this value, not including the quotes. So I'm going to do Control C for this, and then going back to where we were before, I'm just going to press Control V and then go ahead and press enter to run the command. And what you will get back is an object called instance access, which has multiple properties. The ones that are important to us are the IP address, which we will be using when we virtually connect to the computer running multiple instances of our server process, and the credentials object, which contains a username and secret that we will need to use to authenticate ourselves to the EC2 instance. But we still have to run one more command, which is GameLift update fleet port settings, because we need to open port 3389 on instances in the fleet for incoming remote connections. Specifically port 3389 because we will be using a remote desktop protocol to connect to the instance. And port 3389 is the default port for RDP servers to listen on in machines that are running a Windows operating system. Remember that throughout this tutorial series we have been using fleets with Windows-based instances. This exact process for Linux-based instances is a little different, and we will be going over that in the next part of the tutorial. By the way, what I'm about to do you can actually do in the fleet settings page when you click the edit fleet button in the GameLift dashboard in your web browser, but we're going to do it here in the command prompt. So type out AWS GameLift update -fleet -port -settings, and this command will take in a few parameters here. So the first one will be --fleet -id, and as usual it will be the exact same value that we used for the fleet ID parameters of the last two commands we ran. So once again, I don't have the value copied to my clipboard, so I'm just going to take the fleet ID from when we called describe instances. You can take the fleet ID from when you call get instance access as well, and I'm just going to copy the value, not including the quotes, by pressing Control C, and then I'm going to press Control V to paste that value. The next and final parameter that this command takes will be --inbound-permission-authorizations. And the value for this parameter will be in double quotes. So type out a pair of double quotes, and in here type FromPort equal 3389, comma ToPort equal 3389. And this represents the range of ports that we want to open, which in this case is just one port, which is why both the FromPort and ToPort values are the same. Now type comma IpRange equal, and the value for IpRange is a range of IP addresses of devices that you want to allow to remotely connect to the instance using remote desktop protocol through port 3389. You could type in 0.0.0.0/0 for this value and let anyone try to connect to this instance. However, they would still have to pass the authentication check by providing the correct username and password. Or you could find out your IP address through a tool or website. I like to use whatismyipaddress.com, and I like to copy the value, or really you have to copy the value by where it says IPv4, so I'm going to go ahead and copy it, go back to the command prompt, and then paste the value, and then add /32, and the /32 is basically a subnet mask denoting that this is an IP address pointing to one single machine. Therefore, you are only opening port 3389 to the machine that you are currently working on and no one else. So only you will be able to remotely connect to the EC2 instances in this fleet and authenticate yourself to the server by entering the correct username and password. Lastly, type protocol equal TCP in all caps because we're going to be using the TCP protocol here, and press enter. And you should get an object containing a fleet ID property after running that command. Now I just want to quickly note that I'm not actually sure if you can use a IPv6 address for the IpRange passed to the inbound permission authorizations passed to the update fleet port settings command. It's just that when I went to whatismyipaddress.com, link to that website will be in the description below, I did not see an IPv6 address, so I used the IPv4 address. Also, I'm not sure about the subnet mask that you would use with a IPv6 address. Also, don't worry if you missed any of these commands, they will all be in the description below. But now let's actually remotely connect to the EC2 instance in our fleet by running a program called Remote Desktop Connection, which should already be downloaded on your computer if you are running a Windows operating system. So go to the search bar down here and type Remote Desktop Connection and select the best match. That should launch the Remote Desktop Connection program, which should be a window asking for an IP address value for a field labeled computer. Please ignore the IP address on my screen that was pre-populated in this text box. That was because Remote Desktop Connection saves the IP address value from the last time you successfully connected to another computer remotely. So I'm going to get rid of this value and type in this text box to the right of where it says computer the IP address of the machine we want to remotely connect to, which, looking back at the command prompt, specifically in the result from when we called AWS GameLift get instance access, is the value for the IP address property in the fleet access object, not including the double quotes. So in my case, it is going to be 54.16.1.224. And then once you have the IP address typed out in this text box, go ahead and click the connect button. And that should open up this prompt asking you for a set of credentials for authenticating yourself in order to further prevent the wrong person from remotely connecting to your EC2 instance. For the username and password, just use the username and secret values respectively from the credentials object inside the instance access object returned from GameLift get instance access. So for me, and I believe for everyone watching this video, the username should almost always be gl-user-remote, but the password will be different for everyone. So for me, it's P U7 and Q, S and X T 603R ECC. By the way, the password is case sensitive. Then when you're done typing all that out, click on the OK button, and then you will be prompted again with another window asking you the identity of the remote computer cannot be verified. Do you want to connect anyway? Just go ahead and click on yes. And if you entered the right credentials, then your screen should go black, and this just means that the network connection to a virtual machine hosted on AWS servers should begin. And keep in mind that this will take some time, perhaps a couple or a few minutes, so go ahead, pause the video, and come back when this process has finished. So once the connection is established, you should see a Windows virtual machine which emulates the EC2 instance in your fleet. And in the desktop background on the top right, you will see information about the instance such as the host name, the instance ID, the IP addresses, the region zone, the instance type, and the instance architecture. On the bottom you should see Windows Server 2012, and on the left you will see some application shortcuts. So first I want to show you guys where your game server build files are located. So click on the File Explorer icon at the bottom of the screen to open up File Explorer. Double click the local disk C drive and then double click the game folder. And you will notice that this is almost exactly the same as the Windows Server folder inside our projects directory on our local machine. So I'm actually going to pull up the project directory on our local machine in File Explorer, specifically the Windows Server folder, just to show you guys that it's pretty much exactly the same, except that on our local machine we have the install.bat file. Now let's look at the server logs on the EC2 instance, because that will help you guys debug a lot of issues, whether it's server processes failing to start or crashing midway through while they're in progress. So the server logs will normally be located in the game folder, specifically in the folder named after your project. So in my case, it's going to be GameLift tutorial. So I'm going to double click on that to open it. And then from here, click on the save folder, or double click the save folder, and then click on the logs folder. And this is where the logs for all of your server processes will be located. Notice how each log file is named GameLift tutorial with a underscore and a number appended to the end of the name, except for the first one, because again, a separate log file is generated for each running instance of your server executable. And although you can't see it here, but as the server process restarts, new log files will get made and then the old log files get renamed to include the word backup. So this folder can contain way more text files than what you see right now. But these 5 text files with these specific names will normally always be the latest logs. Or let's say you configured your fleet to have 10 server processes running concurrently on each instance. Then instead of 5, it would be 10 text files with these specific names, but going from _2 to _10. And again, those will be the latest log files, along with any other backup log files from old server processes. And again, since I just started this instance backup, we don't have any backup logs because none of the server processes have ended and restarted yet. You can double click any of the text files to open it up in the virtual machine, but keep in mind that in this tutorial I personally decided not to include debug files and package builds to keep the overall size of the build to be significantly smaller, so that uploading the server build to GameLift would be a little quicker. Therefore, if your server does crash, then you may not be able to get the exact exception or line of code that caused that crash from these log files, because without the PDB files, certain lines of text in these logs will be very hard to read or understand. Also keep in mind that if you are trying to debug a crash, it is best to be remotely connected to your instances in real time while that happens live, because when a server process crashes in the middle of its execution, the server process restarts right away due to some built-in logic in these EC2 instances. Note that this is in the case of fleets in the active state. If your server process can't even start successfully, then you will notice that the fleet will be in the activating state for a while, trying to start your server process multiple times until it finally gives up, and then the fleet will enter the failed state. At that point, you can remotely connect to your EC2 instances in the fleet to debug why the server process could never start successfully. Remember that you can only remotely connect into an instance in a fleet that is either in the active or failed state. But going back to the PDB files, if you did choose to include them in your package server builds, then they would be in the exact same location as the server executable in the binaries folder that we chose as the launch path for each server process in the fleet configuration settings. So if we go back to the folder named after our project, which in my case is GameLift tutorial, that would be in this binaries folder, specifically the Win64 folder. As you can see, I did not include debug files with my package server build, so there are no PDB files in this folder. If there were PDB files here and your server process crashed, then you would be able to see in those log files the exact stack trace with line numbers that led to that crash. Since we don't have PDB files in here, you would have to use or create a tracing tool that would allow you to read the memory addresses in the stack trace in spots where it says unknown function. Otherwise, you won't really have an idea of what the function or line of code that caused the error is. Now, if you do want to make your life easier while debugging a deployed server build and don't care that much about file size and performance, then before you package your project in Unreal Engine, go to File, Package Project, and then Packaging Settings. Then they'll take you to this window here. Scroll down to where it says in the project section include debug files, and then click on the checkbox. To have a check mark in the box to enable this option. Looking back, I think that including debug files, specifically PDB files in your package server build is okay because one, obviously it will make it easier to debug because the server logs in the event of crashes or stack traces will include function names, class names, variable names, specific line numbers, and more. And two, AWS is pretty secure, so I don't think anyone will be able to hack into your EC2 instance, and even if someone does, then the least you will be worrying about are your PDB files. So as long as you don't distribute your package server to anyone, then only you will have access to it on your local machine and on EC2 instances in your GameLift fleet. Now the question becomes, should you include debug files in your package client builds that you will actually be distributing to other people? So PDB files can be used to gain a lot of information about the code behind your project. Therefore, if someone were to try to reverse engineer your game, PDB files would definitely be helpful, but on the flip side, it will make it much easier to debug client issues and crashes because once again, the log files generated will have function names, class names, variable names, specific line numbers, and more. I can definitely see an argument for both for different reasons. For example, there are a lot of big name games like Valorant that are built in Unreal Engine that don't include PDB files in their client builds. But then Unreal Engine is already open source, so technically a lot of code is already out there availably open to the public. Ultimately, the choice is up to you on whether or not you want to include debug files in your package client or server builds, but I think I'm going to leave this option enabled. Although I will not be repackaging the server and client, looking back, I personally think that it is beneficial to include the PDB files, meaning that the benefits outweigh the cons because it does make debugging a lot easier, and most of the time while making a game, the game will be in a debug or development phase for a long time until it truly reaches that release phase when the game is so optimized and contains so few bugs that you have better and more efficient ways to debug your game at that point. Now, just to better show you guys what I mean, I'm going to show you guys the logs of the tutorial project after some random modifications that I did just for testing purposes, not for you guys to copy, that crashed while playing in the editor. One of these log files was generated with a PDB file, the other one was not generated with the PDB file. I'm going to start with the one that was generated with the PDB file. So as you guys can see here, so kind of towards the top, so I'm going to scroll a little bit to the right, it'll actually show you guys, by the way, I'm at the very bottom of the file because this is, when the game crashed, and this is the last stack trace, the last call stack that appears before, the game crashed. So over here, it actually tells you the exact line of code. So it's in the move forward function, something in the move forward function. Actually, again, if I go a little more to the right here, it was in the move forward function in the GameLift tutorial character class, and it actually gives you the exact line of code. Now, again, I added some code off screen to purposely crash this game just to show you guys the difference in log files with and without a PDB debug file. So as you guys can see here, the log is very descriptive when you have the PDB file included. Now, if I go to the other log file that was not generated with the debug file, you'll notice that that exact line that we were just looking at the very end of the log file, when the game crashed and you get the call stack printed out, it now says unknown function. So you'll notice sometimes that parts of the stack trace will be replaced with unknown function. So you would not know where exactly in the code the game crashed just by looking at these logs that were not generated with debug files. With that said, let's go back to remote desktop connection. And another thing that I wanted to discuss while we were in this binaries Win64 folder is that there's a hacky way of changing the game server executable that this particular instance runs. I'm not going to actually do it on video, but I will just briefly go over it in case anyone needs to quickly test some new code changes made to the server and they don't want to re-upload a new build and make a new fleet. So essentially what you can do is, after building your project in Visual Studio in any server configuration, you can copy the server executable, which is usually in the local projects directories binaries Win64 folder. So right here, for example, paste it somewhere else on your local machine, change the name, copy that renamed executable, go back to the games binaries Win64 folder in the instance, paste the newly compiled renamed server application in this exact folder, and then change the name of the old one inside the instance originally, and then change the name of the newly pasted one in the instance to the original name of the old one. And then you have to go into Task Manager. So if I right click this Windows icon here, you can select Task Manager from here. So yeah, then you have to go into Task Manager. If I click on more details here to expand on Task Manager, you have to end all the Unreal Engine executable tasks so that the server processes restart using the new server application. Keep in mind that the renaming of the server file in the instance has to be done really quickly. Also, I'm pretty sure that this only works when the server was modified in code only. For example, this won't work if you added a new asset to a map in your game. I believe in that case you would have to repackage the server, re-upload the build, and create a new fleet for that kind of change to show up in the instance. But the reason that I did not want to do this on video is that I don't really promote doing this hacky method to change the game server executable really quickly, since it's not safe to abruptly end running server processes while players are connected to them. Also, changes that you make on an individual instance level do not get applied to the rest of the EC2 instances in the same fleet. The only way to change all the instances in a fleet at once is by changing a fleet's configuration settings, either through the AWS CLI or through the GameLift console. So in conclusion, this method can be useful if you just want to test a small code change in your server really quickly when you have one instance running with no clients currently connected. Also, just another quick reminder, since we are in the Task Manager, each EC2 instance in your GameLift fleet has some built-in logic to restart a server process after it ends. So let's say I select one of these Unreal Engine tasks and click on End Task to end the task. You will notice that the task does disappear very briefly, but then a new one spins up very quickly, because in our fleet configuration we specified 5 distinct processes to run simultaneously on each instance. So I'm not sure which exact server process I ended, but let's say I ended the one that took in a port value of 7777. Then after ending that process, a new process will start taking in that same port value of 7777 to replace the old one that just ended. And again, I just did that for testing purposes, so I would not recommend doing that in a production environment. Because once again, you don't want to abruptly end a server process that players are connected to. Also, remember that this server process restart logic will occur no matter how the server process terminates, whether it was you doing it manually over a remote connection or the game server quits on its own due to logic that we wrote that quits the server application once the game is quote-unquote over. But this restart logic can stop if an internal error occurs in the instance or in the fleet, whether it was caused by you or something on the AWS side. In that case, you will usually know from the event tab in the fleet page. So in the GameLift console, make sure you have the events tab selected and then click on the refresh button. You'll notice that the latest event for us is of code server process crashed, and the message, if you hover over it to see the full message, says server process exited without colon process ending, exit code 1. Also gives the launch path, the arguments, so you know that this was the process running on port 7781, the instance ID, the public IP, and the game session ID. And also you can expand this message column as well if you want to see more information that way, but either way is fine. So yeah, this event occurred because since we manually terminated the server process, it indeed never got the chance to call process ending before the server process ended. And normally I think this event is actually kind of harmless in our case, because one, we were kind of expecting this, since one, if you do choose to do that hacky method that I briefly explained earlier to quickly swap out the server executable currently running with a new one from your local machine, then you're going to have to manually terminate the process anyway, and in that case it's true, process ending won't get called. But this event of code server process crashed can happen for multiple reasons, for multiple exit codes. So in this case it may be kind of harmless. For example, if you spun up a couple of new clients and try getting them into a match, they can still end up connecting to the server process on port 7781 through flex match and matchmaking, because the server process in the end was restarted, and I don't think anything on the AWS or GameLift side was broken because of this. But again, note that there are times where this event of code server process crash happens for a different reason and a different exit code, and in that case you may have to debug that further, because it could affect things in your instance and in your fleet. So with that said, let's go back to remote desktop connection, because the last thing that I want to go over in this video involve a couple of folders in the C drive folder. So let's close out Task Manager and go to the C drive folder. So in here you will see the white water folder, and this is a folder that contains files used by the GameLift service to manage game hosting. I am not going to go into this folder because it is recommended according to the GameLift documentation that you should not modify the files in this folder. Lastly, although you cannot see it in here because I chose to leave the default setting in my fleet for TLS certificate generation on disabled, there is normally a folder in here called game metadata if you did enable TLS certificate generation in your fleet's configuration settings, and that game metadata folder has a folder called certificates that will include everything for TLS, such as certificate files, which includes a certificate change, a private key, and the root certificate. Again, we did not go over TLS in this tutorial series as it is a more advanced concept that requires more time to understand, but it is still important for multiplayer game development, so I highly encourage you guys to check that out on your own time. And that is pretty much it. Once you're done with everything you need to do in your instance, you can just go ahead and close out of remote desktop connection. And when you do try to quit remote desktop connection, you will be prompted with your remote session will be disconnected. Just click on OK. And that will be all for this part of the tutorial. We managed to remotely connect to a Windows EC2 instance and one of our fleets on GameLift. So if you liked the video, then please like, comment, and subscribe. If you want to support the channel, then please consider becoming a patron on our Patreon. Huge shout out to all of our patrons on Patreon and anyone who has donated to us throughout the channel's existence. And a special shout out to our higher tiered patrons, which include Max Norris, Elise, BioBlaze Payne, Corone Tatum, Keith Perry, and Solar Tricks. Link to our Patreon along with our PayPal, GitHub page, Discord server, and other social media pages will be in the description below. And that is it. Have a nice day and see you guys in part 10.